Hello, this is Mrs. Rapaski, and this video is about electron diagrams doing Aufbau configurations, the noble gas shorthand. This is a video for Chemistry 1 students, in particular for Chapter 5, Quantum Mechanics. For this example, we will do an electron configuration for calcium. So first we find calcium on the periodic table, and we see that it's in the fourth energy level of the periodic table. To start our electron diagram, we'll put the symbol of the element, Ca for calcium, and we always put a colon because that says, ta-da, here's something important to see. When we do our electron diagrams, we'll use the periodic table and we start reading from the upper left-hand corner. We identify each section that we're in, and this says 1s. The 1 is for the first energy level, and the s is for the orbital. We are going to do the shorthand method, so we'll count how many electrons are represented by the boxes on the periodic table for this section, and there are 2, so we will write a superscript 2, and we will call this 1s2. Since the first energy level is finished, we go to the second energy level. We see that we are in the 2s section, so we identify it. There are 2 boxes here for the third and fourth electron in the diagram, and we write a superscript 2 and say 2s2. We continue going across the second row, and we're in the 2p section, so we identify that by writing 2p. There are 1, 2, 3, 4, 5, 6 boxes, so that would be 6 electrons for our configuration. We have now finished the second energy level, so we go down to the next row of the periodic table, which is the third energy level. We see that we start in the 3s section, so we're in a new part of our electron diagram, so we identify that as 3s. We see that 2 more electrons are in this section, so we write a superscript 2. We cross the gap. We see we're in the 3p section, so we write 3p to identify that area of the periodic table. We count across, and again we see we have 6 electrons, and we write a superscript 6. And then, having finished the third row of the periodic table, we go down to the fourth row of the periodic table, which starts with the 4s section. Calcium is in this section. It is the second element in, so we end at 4s2. So calcium's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now, if we look at all the electron diagrams we've done, we notice that we always do the same thing. We read across an entire row, and then we go down to the next row of the periodic table, and we read all the way across, and then we read all the way across, and we go down to the next row, and we keep doing that again and again and again. And when we get to an end of the row of the periodic table, we always notice that we end in this family, and this family is called the family of the noble gases. And they are special because they are known for being chemically stable. So since we always start at the beginning and work our way through, we can look at the electron diagram and see that within calcium's electron diagram, we have 1s2, 2s2, 2p6, 3s2, 3p6, and if we end at 3p6, we are at the same configuration as argon. So there's a neat trick that we can do using that information. So we start with calcium and we write its symbol, but this time, instead of starting at the 1s2, we look at the configuration for argon, and we are going to put this in a box because argon's electrons are arranged neatly into a nice set. And then we notice that we have some electrons left over, and these are electrons on the valence shell. And we add those, and those are the electrons that are active for calcium. Those are the electrons that would be lost when calcium forms an ion. So this is the noble gas configuration for calcium. So as we look at it, we have argon in square brackets, okay, which gets rid of all of this writing. So all of these writings are gone. And then we have just the valence electrons are left. And as we sang in Michael Offutt's song, The Electron Configuration Polka, these valence electrons are shared or lost or gained in chemical reactions when atoms rearranged. So all the atoms we know start 1s2 and 2s2 and then comes 2p6. Since all of the atoms in their ground state start at 1s2, then go to 2s2 and 2p6 and continue on, always ending at p6 if you're going all the way to the row, we can look for a noble gas. Put the noble gas in square brackets and then add valence electrons at the end to see how that makes the element that we're thinking of. Remember, only noble gases can go in the box because only noble gases are in the last column of the periodic table. And those are the ones that all the atoms look up to when they try to form ions. Thank you for watching.